be in Slack answering questions, and we will do Q&A at the end as well. So make sure to ask questions in the appropriate Slack channel. And with that, we will go ahead and get started.
Cool. Thank you for joining me today for Combining the Old with the New, adapting Combine to a variety of older patterns, APIs, and practices. I'm your speaker, Dion. Today, we're going to be talking about how to get started with SwiftUI and Combine, adapting API patterns from older APIs, and then we're going to be giving some closing thoughts and conclusions based on what we've learned today. A little bit about myself. Like I said, my name is Dion. I'm on Twitter at LeoGDion, and I specialize in Swift development. That could be iPhone, iPad, macOS, watchOS, as well as server-side development with Vapor. I've been running my own company, BrightDigit, since 2012, and you can find my company online at brightdigit.com. Not only do I write about business topics and management topics when it comes to iOS development, but I also write quite a bit on Swift tutorials at my development blog, learningswift.brightdigit.com. You can also find my podcast, which is almost up to 70 episodes, and that is at empowerapps.show. We talk about a variety of technical topics in Swift, but also things that might be of interest to CTOs and project managers about what it means to manage a team when it comes to iOS development. So let's get started. Let's talk about getting started with SwiftUI and Combine. Typically, we've seen something like this: a SwiftUI view attached to some sort of observable object. Let's take a look at a really simple example of this. Here's a really simple SwiftUI view called Content View. It has an observable object called Content Object, which is using the environment object property wrapper. The SwiftUI view just simply has a text shown in the very middle of that SwiftUI view. Our observable object has one property, a value, which is an integer stored at 12. But you'll notice that this value has a property wrapper attached to it, published. Well, what exactly does published mean? Published is one of the more simple value publishers that allow SwiftUI to listen to changes based on how that value changes. Now, currently, if you were to run this app, it'll just simply show the initial value, which is 12. So, published is probably one you've used before in an observable object, but there's others as well, such as current value subject. Current value subject is pretty similar to published in that it stores the value. However, there are other ways to do this as well. Here we're using something called a PassthroughSubject. In this case, we set up a PassthroughSubject to receive on a main thread and change the value. Well, let's get into this a little bit more. What exactly makes a PassthroughSubject different from current value subject and published? Well, in the case of a published property and a current value subject, it actually stores the value as it changes. So for instance, if we were to send the value 42 to a variety of these value publishers, we can see that published property and the current value subject will actually store the value. However, the pass-through subject doesn't. It simply just passes it through whatever other things are listening to those changes as they happen. So let's take a look at our content view and let's add a button. We're going to have this button increment the value of our value property on our content object. So we're going to take advantage of this pass-through subject called increment. We're going to send it a void object using the parentheses here. We label it increment. And essentially what we want it to do is every time you tap the button, it actually increments the value. So we know our pass-through action will send in a void value. But then how do we take that void value and update our value property? So this is where sync comes in. Sync is one of the two main ways you're going to use to listen to publisher changes and update the values accordingly. So we added our increment pass-through subject, and we need to store what's called a cancelable. We'll get into this in a little bit. Here we have our sync. Sync will handle every result as it receives. So in this case, every time you push the button, it sends a void object, which then calls the sync, which then increments the value on our self content object. Well, just like with UIKit, we need to make sure UI updates are done on the main dispatch queue. This is where receive comes in. And in this case, we're receiving it on the main dispatch queue so that as that value changes, the UI can be updated accordingly. Next, we need to store that cancelable object. We need to store the cancelable object so that it's properly disposed when our content object is disposed. So we now have a button which will then increment our value. Here's our code within our class. And again, here's our button in action. Now, oftentimes we might want to call some sort of external API and display the results of that external API. Here's an example of an API called bacon ipsum, which just returns random strings with various meat names. This is how we want it displayed in our SwiftUI view. We'll just simply have a words property on our content object, which is a string. Well, how do we set this up? So here's our old content object. Let's add in our code for our words property. We added the words property as well as a words cancelable to take care of whatever actions we do with our API call. We have our URL to the bacon ipsum API, and then we have something here for downloading from the URL and sending words. Now, how are we going to go about doing that? Well, this is going to be our first example of combining an old API with a new one, and perhaps our most simple. Let's go over the first one here, which is system publishers. Thankfully, Apple has given us some extensions to existing APIs, which will automatically create publishers for us. In this case, we're going to first look at URL session data task publisher. Here's our code for downloading that data from bacon ipsum and transforming it to a string. Let's take this step by step, and specifically, we're going to look at one of the built-in system publishers, that is data task publisher. Data task publisher takes in a URL, which is what we're going to be calling, and what it does is it creates a data task publisher. This data task publisher has an output type of a tuple, which contains a data and a URL response. It also has a failure type of URL error, in case there's any issues downloading the data. So then you might be asking, how do we take that and transform that information into a words property? That is a string. Well, you probably heard this term before, but essentially this is the functional reactive programming of SwiftUI and Combine, specifically the functional part. You probably have done functional programming before. Let's say you've converted a series of values within an array using map, taken an optional value and returned another optional value and made sure that it's flattened using flatmap. Removed nulls during conversion using compact map. Filtered out a series of values using filter. Or reduced an array into a single value using reduce. Well, luckily for us, Combine comes with its own counterparts with publishers. Publisher map, publisher flat map, publisher compact map, publisher filter, and publisher reduce, amongst others. So what we're going to do here is we're going to need to use functional programming to convert the value of our data and our URL response with a URL error into a single string. The first thing we can do is use map. While map is typically used for converting data using a closure, in this case, what we're going to actually want to do is grab the key value path and use that to grab the data part of our tuple. Then we can then decode the JSON from that data using decode and pass in a JSON decoder. We know bacon ipsum returns just simply an array of strings, so we decode that array into an array of strings. Next, we need to make sure we handle the error. If we're going to be using it in SwiftUI, it can't have any error type. What it technically has is a never failure type. So we're going to use replace error to remove the failure type and convert it to never. Now, If an error happens, it'll return an empty array of strings. Next, we want to grab the first string from that array. So we use compact map in case it's an empty array to return the first value. If the array is empty, then the publisher won't send any values from that array. Now, in our previous example with increment, we used sync to call the +1 on the value. But there are other things we can do, such as assign. So, as I said previously, map can take in a closure or a key path, and then converts the value accordingly. And in the same way, we could take that publisher output and either use a closure by using sync, or we can use assign to just simply assign that publisher output to a key path. So here's how our old code worked with increment, where it received the value on the main dispatch queue and then called the method within sync. If we're going to use the same method, we take that URL publisher and we can then receive it on the main dispatch queue, receive the value, in this case the new words, and set that to the words property within self. However, we could also use assign to just simply assign that value to the words key path on the content object on self. There are updates to this just recently with wwdc you may want to check out. But essentially, it's more or less the same. In the case of the updates with wwdc, the assign actually can assign on self if it's already an observable object and doesn't even need to return a cancelable. So you may want to check some of that documentation out after this presentation. So here's our complete code, which takes the URL session, calls the URL, and then goes ahead and grabs the data, decodes it using JSON decoder, replaces the error with an empty array, and then grabs that first string. Then we take the result of that URL publisher and on the main dispatch queue, assign it to words. And voila, we get something like this. So we've gone over one of the main system publishers that Apple has given us that extend already older APIs. Let's now talk about how we can observe changes to user defaults using key values and observation. So here's user defaults. All we have to do is extend it with a dynamic property using the Objective-C property wrapper. And then we create, in this case, a property called HealthKit queried. This way we can keep track when HealthKit has been queried in user defaults. So we've created the property with a get and set. Now all we have to do is go ahead and create a publisher by using .publisher and passing in the key value path. In this case, HealthKit queried. This is a really simple way to just simply watch changes to users' defaults. Again, there are some changes with recent wwdc that you may want to check out, but for very simple user defaults changes or with complex types, this is one way you can observe changes to user defaults. So we've talked about a couple of APIs that are built in. Let's talk about a third-party API, in this case, Firebase. How do we deal with changes from Firebase? Well, Firebase gives us a couple of methods to do this. One is add snapshot listener for listening into changes, and the other one is get documents, which is used for just simply getting the data. Both of these methods take in a closure which has two parameters, one for the successful result, which is documents, and that's an optional, and then another one for an error, an optional error, which is in case the call fails. When we get these values, we have to figure out what we're going to do with them and how we're going to deal with them. That is, we need to figure out what is the initial value in our application before we've even called Firebase? And what does the error state mean if we get an error from one of these calls? And when it comes to the initial value, you need to ask yourself these questions. What are you going to be showing to the user when they first launch the app before it's even loaded any data? And what does that mean to the user when there's an initial state? When it comes to that property, is it going to be an empty array, a blank string, or just nil? Are you going to be showing an empty list? Are you going to be showing a busy indicator, or maybe a special message on the screen that says that the data is loading? Similarly, you have to ask, what does an error state mean? Again, what are you going to be showing to the user when an error happens? And what does that mean to the user? Error also could mean a couple other things that you might find confusing. As we mentioned earlier, publishers have two generic types, an output and a failure type. But in some cases, we don't want necessarily the publisher to fail. If a failure actually happens, the publisher will simply just stop. In some cases, we might want a failure as a result, in which case we may want a publisher with a result success failure as the output type, and never as the actual publisher failure type. This is important to know in case you want to actually show the error on the screen and handle it. So, what can you do with an error? If you do have an error in your failure type, one thing you do is what we've seen earlier with our Bacon Ipsum API. Simply replace the error with like an empty array or any sort of value that matches the output type of the publisher. We can convert the error into something other error that might be more useful. In that case, call map error. We could also just simply have our app crash using assert no failure. And lastly, we could use catch to map that error into a publisher of our own. So once we have that data from Firebase, we can easily just store it in a published property and display it using SwiftUI. So we covered a third-party API. Now let's talk about some of the older, more Objective-C-based APIs that Apple has had for quite some time. And that is dealing with delegates, specifically with something like core location. Delegates with core location follow a similar pattern we've seen to a lot of older Apple APIs. Something like this. We see something like a delegate, which has to be an NS object. It has some sort of method to deal with permission changes and some sort of method to deal with data as it's received. The manager then has a delegate property, and that delegate property is weak and can be optional. It has some way to request authorization, so that way the user is prompted, and something to start those updates or call an update. So this is similar to what core location does. Core location manager has its did receive location updates. It has something for did change authorization status. And then the manager has something to request authorization depending on what kind of authorization you wish to request, whether in use or always. And then something to start those location updates, as well as the delegate property we need to store. So we'll have something like this. We'll have our observable object, which will link to the delegate in the manager. The question then becomes is, how do we create these publishers that will be useful to the observable object based on the delegate? How do we keep track, take the delegate and convert it in such a way that it'll give us publishers we can then use and transform into data we can actually display in our view? This is where something like this comes in. This is called a core location manager combined delegate that I've created. It extends our existing core location manager delegate by adding 2 additional methods that create publishers for us. So how do we go ahead and implement something like this? Well, here's what I've created, something called a core location manager publicist. This implements our combined delegate, and it will return the publishers and manage the data coming in from our core location manager. So obviously it needs to be an NS object because most of these older APIs require these objects to be NS objects. And then it has 2 subject properties. One that is a authorization subject, PassthroughSubject. We're not going to be storing these values. We're in fact going to be transforming it and sending it into our observable object. That's why we can use PassthroughSubject. And then we have our location subject, which has the changes to locations and takes those in. We see here we have a location publisher, which then takes in the locations from our location subject and returns those as a publisher. But then we also see an authorization publisher, which has a bit more complex code because of some of the ways that the initial authorization status will need to be sent to our UI. So how do we go about doing this? Well, if we look at our PassthroughSubject for authorized status, it won't receive any values at first. And so in some sense, it'll be nil. However, the way the application actually works is it has an initial status, either not determined if this is the first time the application has run or whatever the previous authorization status was. We need to figure out a way to get that initial status within the publisher. So what we can do is we can grab the initial status and we can use core location manager status. We use just to create a publisher just out of that one value. And then we use merge with so that every change that comes from the authorization subject is then merged with the publisher that is created by the initial authorization status. So the publisher then ends up looking something like this. The core location manager authorization status first, and then every change from our authorization subject afterwards. And that's why we have what we have here. Now, something else you might notice is we have a call at the end, erase to any publisher. Why do we have that here? Well, similar to how SwiftUI views work, every time you transform or change a view or a publisher, we're going to be adding more to our generic type. So as you can see here, every transformation that occurs here changes the type underneath. This can make creating a protocol of some sort or implementing this much more difficult than it really needs to be. What we really care about is what the output type is and what the failure type is, because in the end, that's what we're going to be using. Therefore, we can use erase to any publisher to then reduce this type down to an any publisher. This means that our protocol simply has to specify that it's any publisher of these two types. And then when we implement it, all we have to do is call erase to any publisher to remove all the generic typing that has been created using the functional transformations. Lastly, let's take a look at how we take the data in from our CL manager using the delegate calls. So so as you can see here, we get our locations array, and we send that locations array to the location subject, since that's the type that it takes. It is often suggested that we do something with the error. So this is something to look into in the future, because we should handle the error in case there's any location manager errors and display those on the UI. And then we need to handle authorization changes. So again, we just simply send the CL authorization status to our authorization subject. And so this is the final code for our publicist. Now let's take a look at core location object. So now that we've seen our publisher or combined delegate implementation, let's take a look at how core location object works. So as you can see from the top, we have our initial authorization status, which is not determined, as well as a optional CL location for if location has not been received yet. We're going to be storing our manager and our publicist, as well as our cancellables, and we're going to be using store in to store our cancellables into the array rather than assigning them as we had seen previously. So in our initializer, we have to just simply create our manager. We then create our publicist. And then lastly, we assign the publicist as a delegate of our core location manager. Lastly, we store our manager and our publicist. Now, how do we go ahead and deal with the publishers that we create? We can then call publicist.authorization publisher and publicist.location publisher. We then need to make sure that if we do receive authorization, we begin updates. So we have a method in here called begin updates to start receiving location updates. We then store the cancelable in that cancelable array that we created. Then we want to make sure that we restore the authorization status. So we receive in the dispatch queue the authorization publisher changes as well, and store those in authorization status. Now, how are we going to deal with actual location changes? So we have our location publisher, and we have to convert that array, since the way update locations works, it gives you an array of locations and sequence of their changes. And we need to somehow flatten that. And we're going to be using here publishers.sequence to create a publisher from an array. We also see here a flat map. What does flat map do actually with a publisher? So let's talk about these. First of all, let's talk about integrations with flat map and what we're doing here. With combine, we can actually take a publisher and return another publisher. So let's take our Bacon Ipsum API that we had previously and let's have it update every so often. Luckily for us, Apple has provided extensions to timers to create publishers based on timers. In this case, we're going to be calling the Bacon Ipsum API every few seconds to pull a new string or array of strings from the API. Luckily, Bacon Ipsum pretty much changes the string and returns a random string every so often, so this should work correctly. So we already have our URL publisher. What we need to then do is call timer.publish with the number of seconds, make sure we do it on the correct run loop and in what manner, and then we call autoconnect to make sure that that timer is created. We can see here that we have flat map called. We don't really care about the timer, that's why we have an underscore here for the argument, but we do care is to return that URL publisher so that the URL publisher is called every time the timer is started. Therefore, rather than having a static string here, we'll have something more like this. So as you can see, it automatically changes the string every second because it keeps calling the API on top of our increment button working as well. So in the same manner that the timer will return a new publisher, we're going to be doing the same thing with flat map, where we're going to return a new publisher based on that array. We also see here that publishers.sequence. Publishers.sequence is actually another built-in publisher. There are a few that we can talk about. One is future, for when we have to handle asynchronous callbacks. You can actually call future to handle those callbacks as they happen. There's just, which we saw previously, which takes in static values and creates a publisher out of that. And then lastly, what we're doing here is we're converting an array into a sequence publisher so that that array acts as a sequence of values that are outputted by the publisher. So each location will then be sent out individually to the publisher. We need to make sure that we convert each value into an optional CL location, since that's the type that our core location object takes. And then we have to make sure we receive it on the main dispatch queue. We then assign the value to our location property and store that cancelable in our cancellables array. So that's delegates with core location and how to use it in combine. This is actually a pretty useful pattern that you'll probably be using in a lot of other Objective-C based APIs. Recently, I've used this in my app Heart Twitch, which is a live streaming health kit Apple Watch app to live stream your heart rate as you are playing games or doing presentations. And so with like health kit workouts, I've used the same pattern of publicists creating publishers and using them within my content object. If you're doing something with User Notification Center, this will be useful as well. And with the variety of data that can come from core Bluetooth, this will be super useful if you want to publish, say, different specifications or properties from a Bluetooth device. We've gone over a lot today, so let's go over exactly what we talked about. First, we started off with getting started with SwiftUI and Combine and some of the basics there. We then talked about using value publishers like the publisher property wrapper or content value subject, or if you don't need to actually store the subject. We talked about using value publishers like the publisher property wrapper, current value subject, or in the cases when we don't need to store the value, there's always PassthroughSubject as well. When dealing with results, we talked about either passing in a closure, using sync, or assigning it to a property using assign. And similar to how UIKit demands that changes to the UI happen on the main dispatch queue, we have to make sure we do the same thing with SwiftUI and Combine. We talked about how it's important to store cancellables so that properties are deallocated properly. We talked about calling APIs with system publishers like the data task publisher. We talked about transforming data with functional programming, as well as observing values in user defaults using key path observers. We talked about designing your application with initial values and errors in mind. We talked about built-in publishers like Just, Future, and Sequence, as well as how to adapt delegates by creating publishers using those delegates. And lastly, we talked about integrating multiple publishers with FlatMap. If you're interested in learning more, here are some resources I highly recommend you check out. There's Joe Heck's book available on his GitHub page, which details some of the various ways Combine can be used. I highly recommend checking that out. Donnie Walls has a lot of great posts as well as his book, Practical Combine, which you should also check out. And I also did an interview with him in episode 47 where we talked about Combine quite extensively, and I highly recommend checking that episode out as well. There's a couple of sample repos you can check out. There's one in my personal repo, which is a playground for which has a sample for a publisher. And then if you're interested in how other older APIs can be used with Combine, check out my Combine API Harvester app on my BrightDigit user as well. Lastly, if you're interested in following my blog posts, check out my development blog at learningswift.brightdigit.com. And of course, I'm on Twitter at LeoGDion. I'd love any feedback you have on this topic, as well as any questions you have. Thank you so much. It's been fantastic to present at 360 iDev once again. Thank you.
Awesome. Do you think Apple will eventually just create Combine extensions to all their APIs for us so we don't have to roll our own?
No. Just based on what we saw this year from WWDC 2020, they didn't come out with a lot of new stuff. I posted a link to the new assign for publishers that's available in iOS 14 and all the WWDC 2020 OSs, but that's about it. There really isn't a lot of new stuff that came out this year, and if they were going to do it, they were going to do it this year. Whereas if you look at like SwiftUI, there's like a ton of new stuff in the SwiftUI this year. So I'm kind of thinking that they're more or less done with Combine as far as extensions to existing APIs.
Gotcha, yeah. What is the minimum version to use Combine? Can we use it with iOS 12?
No, just iOS 13. There is some open source projects that I'll link to in the Slack that are trying to kind of open source Combine and kind of home built it so that you can use it on older OSs or on Linux. And I'll link that in the notes. But as far as like the official Apple Combine, it's only iOS 13 and 14 and up.
And we've got one more. Any suggestions on how to diagram the data flow throughout an app? Tracing these streams and operators seems like it could get quite messy.
I am not a big diagram person, so I'm not really good at answering that question. But there is a app that I just posted in the Slack called Timeline that is a really excellent debugging tool I've heard a lot of great things about, so you should definitely check that out if you want to debug your Combine publishers.
Cool. Kendall asks, I was wondering about using Combine to adapt different stuff to publishers.
I was wondering. Kendall, what? Maybe give me a little bit more detail what you're looking for. Because it's not hard to do. I think the biggest API is Delegates, which is what this talk was about. I think once you get over that hurdle, that gives you a lot of benefit as far as being able to use it in SwiftUI or even UIKit as well.
We'll give Kendall a minute. He's typing the joys of live Q&A on Slack.
Yep, and then I posted a link to my blog post. I'll have more of the details from this talk on my blog as well, about like specifically core location, which I think is a prime example of that delegation pattern that Apple's been using for 10 years. And if you have any questions, I will also post my email address as well as my Twitter. But yeah, any other questions?
Doesn't look like it. Kendall just said it was really more saying that he was happy you showed it some examples of adapting. So
thank you. Thank you.
Yeah. All right. Well, thank you, Leo, for doing that. It was an excellent talk despite my self-inflicted technical difficulties. So everyone can rewatch the video to see it and see the director's cut of this.
Yeah.